Stan Gibilisco here, operator of amateur radio station W1GV Whiskey 1 Golf Victor, mainly to be found on the 20-meter band, operating CW with 10 watts output and PSK 31 with 7 watts output. But I don't do much transmitting anymore, mainly listening. But once in a while, if you're in an exotic location and I want a challenge, I'll try and get ya. Anyway, I'd like to continue the discussion of the VLF converter hack that I described in a video just a day or two ago. You can look at the dates on these videos and search around for the VLF converter hack. It's in my amateur radio playlist, and I describe in that video how I connected an old Drake T4X transmitter back in the 1970s and a Drake R4A receiver together in order to obtain reception on the very low frequencies. Remember, the very low frequencies are those frequencies roughly in the range of 10 to 30 kilohertz, not megahertz, but kilohertz. Well, I also was interested in receiving signals all the way down as close to zero as I could get, below 10 kilohertz. The problem was that below 10 kilohertz there was an awful lot of noise from what we call dirty electricity or line noise, which would create a havoc below 10 kilohertz. And of course, if you got down all the way to within a couple of kilohertz of the amplitude modulator carrier frequency, that signal would overwhelm the receiver and you couldn't hear anything anymore. Someday I suppose I'll try to build a modified version of that circuit in which a balanced modulator is used so that that carrier is suppressed. But for now, this is I just did that experiment when I was in high school, and I used to do a lot of experiments in high school. I used to stay after school, sometimes an hour, 2 hours after school, and in Minnesota in the winter, of course, it would get dark, and it'd be dark by 4:30 in the afternoon, 16:30 if you're into military time, even before we would have supper. Of course, those were the days that I wasn't on the swim team and was preoccupied at those hours of the day, but I would stay after and I would do experiments in the hallways with lasers, and I tried to build a particle accelerator in chemistry class, and my teachers were kind of intrigued by it. They were very gracious. They let me fool around, and I think that was how I got into this scientific kind of frame of mind. That's the way that scientists make discoveries. They play around. They're just trying to figure out what'll happen. Well, in that video, I describe how I did this and what happened. The problem was that noise down below 10 kilohertz. And I wanted to try and actually communicate below 10 kilohertz, so I built a little transmitter that would work between 3 and 10 kilohertz. And it actually used vacuum tubes, and I guess I needed to refine the design a little bit because I would get a shock off of the chassis of that thing from the 250 volt power supply for the vacuum tube. But it generated a watt or two, and a watt or two, 1 or 2 watts, and I would feed that into a long wire antenna and hope to communicate over long distances. Never did work. I managed to communicate a couple of blocks, maybe an eighth of a mile, maybe a quarter of a mile if I was lucky. Just didn't have the power and didn't have the size of the antenna and the antenna design and the space to put it up that I needed. Anyway, what I decided I would try once I had connected this antenna, my 20-meter vertical antenna on the roof of the house, to the microphone input, coaxial cable went right to the microphone input of the T4X, and I tuned up and down in spot mode on AM and listened to the sidebands. That's how I managed to hear signals at very low frequencies. It worked up to about 60 or 70 kilohertz, and then the audio circuits in this transmitter became less and less effective, and so upwards of 70 or 80 kilohertz I couldn't really receive anything. But I was interested in those frequencies way down there, actually in the audio frequency range. So I took an audio transformer with a center tap in the primary, and I believe it also had a secondary center tap that I did not use. But I connected the primary winding as shown here. What I did was I connected a short wire just laying on the floor of my radio shack, which at that time was a fallout shelter in the basement of the house, just enough wire to pick up a good deal of that dirty electricity noise, and I decided I would try to feed it back into the circuit in addition to the signals from the main antenna. This switch right here allowed me to reverse the phase of this feedback, so that if the objective, of course, was to get the electromagnetic dirty electricity artifacts from this noise antenna to cancel out the dirty electricity artifacts from the main antenna. I also figured that the main antenna would be a lot better at receiving signals than the noise antenna would be, because the main antenna was out there in the open on the roof of the house. The noise antenna, contrary-wise, was indoors where signals would not be nearly as strong. So that was the idea, to cancel out the noise but not the signals. And because the wavelengths at this frequency range of 3 to 10 kilohertz, the wavelengths are so long that no matter where I put this noise antenna, as long as it was within a reasonable distance of the main antenna, we could expect that this dirty electricity artifact would be either in phase coincidence or phase opposition, depending on the position of this switch and the orientation of this noise antenna. So I had the switch, and then the potentiometer was to vary the strength of this input, this injection artifact that I wanted to use to try to cancel out the noise from the main antenna. I didn't want to put that potentiometer in the main antenna line for obvious reasons. So I could adjust the signal strength all the way from 0, which would be with this arrow pointing down at the bottom of this resistor symbol, to maximum all the way up at the top. So I adjusted this, and I fooled around with a switch, and I connected this in different phases, 180 degrees out of phase on either side of a transformer winding, as you may remember. If it's center tapped, whatever the phase is here, it's going to be 180, or phase opposition, technically speaking, phase opposition over here. Well, I don't remember which position of the switch I used. I don't exactly remember the value of this potentiometer either. Probably kilo ohm, 10 kilo ohms, maybe 500 ohms. I don't remember exactly. But I do remember that I was able to find a setting of this potentiometer and this switch in which the noise at this main antenna between 3 and 10 kilohertz was reduced about 5 S units. 5 S units. Now an S unit, in most radio receivers, an S unit corresponds to plus or minus 6 dB. So 5 S units of noise reduction would be 30 dB of noise reduction. That's a lot. That's really effective. Now what about the signals? Didn't affect them at all. So what I in effect got was exactly what I sought after, and once again I was just elated. I thought, this is really the way that that discoveries are made. Of course, the ideal situation would be to have my entire arrangement way out there, far, far away from all the utility lines, out in the middle of the ocean or the middle of the country in Wyoming or Montana or someplace like that. Even to this day, I contemplate finding a spot off the grid way out there in Montana somewhere. There are actually a couple places that interest me. The problem is I don't have the money. Doesn't cost much though. They're like campsites. They're glorified campsites, cabins out there in the wilderness, far, far, far away. And I would like to try some of these experiments out there where I wouldn't have to have this noise canceling arrangement, which, as venerable as it was, this noise canceling arrangement right here, well, I guess I should also include the transformer in that. As venerable, as wonderful as all this was, there's just nothing like getting out in the middle of nowhere. Anyway, I did this, I tried it, it worked, and once again, that's the way that scientific discoveries are made. This wasn't anything all that profound, but it was cool from a hobby point of view. So watch the video, VLF Converter Hack, along with this one, and if you're of a mind to, try these experiments for yourself. I don't know if you have a T4X and an R4A to do it with, though. That might be a problem. I think it'd probably work with some other older radios. Otherwise, you're going to have to build your own VLF converter. Maybe someday I'll do that and I'll show you the design for that. Stan Gibilisco, W1GV, Whiskey 1 Golf Victor, amateur radio station operator, signing off for now. 73